Look up at the night sky for a moment. Billions of stars shimmer in the darkness, like a vast cosmic ocean stretching beyond imagination. Each one silently whispers a question that humanity has carried for thousands of years. Are we truly alone in the universe? This question has inspired philosophers, poets, scientists, and dreamers across generations. It fueled myths of gods living among the stars, legends of worlds beyond Earth, and now entire branches of science like astrobiology and astronomy. For centuries, our ancestors had only imagination, but today, humanity has something far greater: technology. We have built instruments so advanced that they can peer across the unimaginable gulf of space and bring back evidence, real evidence of what lies out there. And one of these instruments, the James Webb Space Telescope, may have just found the most tantalizing clue yet: a strange world, light years away, where something in its skies may be whispering, "Life exists here." That world is called K2-18b. Before we dive into this mysterious planet, let's talk about the machine that made the discovery possible. The James Webb Space Telescope, JWST, is not just a telescope, it's an engineering miracle. Launched in December 2021 after decades of planning and billions of dollars in funding, Webb was designed to do what no telescope had ever done before. It sits a million miles from Earth at a location called L2, far from the interference of our planet's atmosphere. There, shielded by a tennis court-sized sunshield, Webb stays cold enough to detect the faintest whispers of light coming from the distant universe. Unlike the Hubble Space Telescope, which mostly saw visible light, Webb is tuned to the infrared spectrum. Why infrared? Because light from the earliest stars, the faint glow of distant galaxies, and the delicate chemical signatures of alien atmospheres all reveal themselves most clearly in infrared. In other words, Webb was designed to answer questions that Hubble could only dream of. Questions like, what were the first galaxies? How do stars and planets form? And most hauntingly, could life exist on worlds beyond Earth? And that's exactly where our story leads, because Webb's gaze eventually turned toward a star system 120 light-years away, and found something extraordinary. Orbiting a small red dwarf star in the constellation of Leo is a planet that, for years, seemed fairly unremarkable. This is K2-18b. Discovered back in 2015, K2-18b belongs to a category of planets called sub-Neptunes. These worlds are bigger than Earth, but smaller than Neptune, ranging somewhere between a rocky planet and a gas giant. What makes them mysterious is that we don't have any examples of them in our own solar system. We know rocky planets, like Earth, Mars, and Venus. We know gas and ice giants, like Jupiter and Neptune. But this in-between class, sub-Neptunes, doesn't exist here. So what are they really? Are they covered in thick atmospheres of gas with no solid ground? Do they hide deep oceans beneath their clouds? Or are they something else entirely? A new kind of world, unlike anything we've ever seen. For years, K2-18b was just another mystery in the catalog. But then came Webb. When the telescope observed starlight filtering through K2-18b's atmosphere, what it found shocked the scientific community. The data was astonishing. Webb detected water vapor in the planet's atmosphere, already an exciting discovery. Water, after all, is one of the essential ingredients for life as we know it. But there was more. Alongside water vapor, scientists also found methane and carbon dioxide, gases that can hint at complex chemistry happening on a planet. And then came the real bombshell: the potential detection of a molecule called dimethyl sulfide, or DMS. Why is this important? Because here on Earth, DMS is almost exclusively produced by living organisms, specifically by tiny microorganisms in the oceans. In fact, when you smell the faint, salty scent of the sea breeze, that's DMS in the air. So when Webb picked up hints of this molecule in the skies of K2-18b, scientists couldn't help but ask, could this be the first real biosignature we've ever found on an alien world? But there's a twist. K2-18b orbits a red dwarf star, much smaller and dimmer than our Sun. Red dwarfs are tricky hosts for life. On one hand, they live for trillions of years, giving life plenty of time to evolve. But on the other hand, they can flare violently, blasting planets with intense radiation that could strip away atmospheres or sterilize surfaces. Yet K2-18b seems to hold on to its thick atmosphere. It orbits close to its star, much closer than Earth is to the Sun. But because its star is cooler, the planet sits in what scientists call the habitable zone, or the Goldilocks zone. Not too hot, not too cold, just right for liquid water to exist, if the conditions are right. And here's where it gets even more fascinating. Some scientists now believe K2-18b may belong to a new category of planets entirely, Hycean worlds. The word Hycean comes from hydrogen and ocean. These are worlds larger than Earth, wrapped in thick hydrogen-rich atmospheres, with vast global oceans beneath. Imagine an alien Earth where most of the surface is water, deep, endless oceans stretching farther than the eye can see, hidden under skies of hydrogen and methane. Surface temperatures on such worlds might reach nearly 200 degrees Celsius, far too hot for humans, yet still within the range where microbial life could survive in the oceans below. This broadens our definition of habitability. For decades, scientists searched mostly for Earth-like rocky planets. But if Hycean worlds can support life, then the universe might be teeming with possibilities, far beyond what we once imagined, and K2-18b could be the first real example. Of course, science demands caution. The detection of DMS on K2-18b is still tentative. The signals Webb picked up are faint, and there are many possible sources of error, from stellar activity to the limitations of our instruments. It will take years of additional observations to confirm whether DMS is truly present. And even then, scientists must be certain that no non-biological process could explain it. In other words, this is not yet proof of alien life. It is a clue, a very exciting clue, but a clue that requires patience. Yet the very act of detecting such molecules at all shows how far we've come. From staring at the stars with naked eyes to now analyzing the chemical fingerprints of distant worlds, humanity has crossed a threshold we once thought impossible. But let's imagine for a moment. What if K2-18b really does harbor life? Perhaps vast oceans filled with alien microbes or ecosystems beyond our wildest imagination. The discovery would change everything. It would mean Earth is not the only cradle of life. It would force us to rethink our place in the cosmos, not as a lonely exception, but as part of a living universe. Philosophy, religion, science, and even human ambition would be forever transformed. We would no longer ask, "Are we alone?" But instead, who else is out there? And perhaps, one day, can we meet them? For now, K2-18b remains a mystery. But it is a mystery that pushes us forward. Future telescopes, on the ground and in space, will continue studying worlds like it. We may soon capture direct images of exoplanets, not just their spectra. We may one day know if alien oceans truly ripple beneath K2-18b's hydrogen skies. And when that day comes, humanity will have taken its greatest step yet in answering the question that has haunted us for millennia. Are we alone in the universe? So next time you gaze at the night sky, remember this. Somewhere out there, on a distant star, a world like K2-18b may already be alive, and thanks to the James Webb Space Telescope, we are closer than ever to finding out. What do you think? Could K2-18b harbor life, or is it just another mysterious planet in the endless sea of stars? Let me know your thoughts in the comments below. I'd love to hear what you think. And if you enjoyed this journey into the unknown, don't forget to like, share, and subscribe. Together, we'll keep exploring the wonders of the universe. Thank you for watching, and I'll see you in the next video.